Welcome back to lesson 18.2. In this lesson we will look at the linear search, understanding how it works and some technical facts about it. This could come up in the A-level exam. So we'll look at how to turn the linear search code that we developed last lesson into a linear search function. We'll talk about how fast the linear search function is, the number of operations it takes for the computer to carry out a linear search, and we'll learn how to use trace tables to trace the progress of a linear search. In the last lesson we wrote the code for the linear search and I left you with the task of turning that into a linear search function. So here it is. We pass target, the search term, as a parameter. We have the for loop that traverses my list, and if we find a match, so if my list at the counter, my list square brackets I, matches the target, then we return true. And if we get to the end of the list, we've been through every item in the list and haven't found a match, then we return false. You'll notice this is slightly simpler than the main program code. For one thing, we don't need to use break because the return command will not only send the value true back to the main program, but it will stop the function as well. So we don't need a found variable, and we can simply return true, or if we get to the end of the whole loop without finding a match, then return false. So it's neater code than the main program code that we needed to write, and in fact we would nearly always write linear search as a function like this. It's a much neater way of programming. Before we continue, let's have a quick look at the use of mylist within the search function. You can see that mylist is used as a variable within the function, but not passed as a parameter. We can do this because we're not altering mylist at all. We're simply looking at it within the function, and we're allowed to do that without having to pass it as a parameter or use it as a global variable. This may be different in other programming languages, but in Python there's no problem with looking at mylist from within the linear search function. We have to think about how long it might take us to find an item in a list using the linear search method. In the linear search, the computer has to look at each item in the list. It can stop when it finds a match. Now, supposing we called each loop one operation, how many operations would it take for the computer to find an item using the linear search method? Well, we could be lucky. We could find the thing we're looking for at the very start, the very first loop, and we'd call that our best case. So our best case would be that we find the item in the very first item in the list, the very first loop, and that would take one operation. The slowest, the most operations, is if our item is the last item in the list, or perhaps more likely if it's not in the list at all. In that case, the computer has to look through every single item. It has to look everywhere to be certain that the item is not in the list. And in that case, it would take n operations, where n is a conventional expression that we use to mean the number of items in a data structure, such as a list. So if our list has 1,000,000 items in it, it will take 1,000,000 loops to search through the entire list. On average, we'd probably take about half n operations. So to look through a list of 1,000,000 items would normally take about 500,000 operations. As a rough estimate. We sometimes want to compare different algorithms, different ways of completing a task. And when programmers are comparing algorithms, trying to decide which one to use, they often use something called big O notation. We'll do a lot more about big O notation in week 19. But for now, suffice to say that when we're talking about the number of operations, we often talk about the worst case. And in the linear search, the worst case is n. We would write it as big O, n is n. That means it takes as many loops as there are values in the list to find the item that we want. And so obviously when we're dealing with very big values, remember some of the big social media companies like Facebook have billions of users. Using linear search to find an item would take a long time, even on a really fast computer. In the exam, you could see linear search, the linear search function written in pseudocode. And so I've given you an example of what that might look like, and I've also numbered all the lines because again you could see that in the exam. It's quite similar. I've set the minimum and maximum values for the search as variables because you could see that. It's basically the same. Obviously it's basically the same function, but I've just written it out using some of the conventions of pseudocode. I don't think that will confuse you. If you saw that in the exam, you'd still understand it. And finally, we might write a trace table. We might be asked to do a trace table to trace the process of a linear search. If so, it will be quite a small example. So I'm just going to quickly do one of those on the screen for you. Let's say that we've got an array with the values 09, 34 and 8. Remember, arrays don't have to be, arrays or lists, they don't have to be sorted. The linear search will work whether the list is sorted or not. And let's say we're looking for a target value of 9, or secondly, a target value of 99. As you can see, 9 is in the list and 99 isn't, so we get slightly different trace table results. So start to build a trace table. You can build it to match the pseudocode algorithm that I provided because that's got numbered lines and that makes it easier. Remember how we build a trace table, a column for every variable. So let's just see how that might start. So at line 1, the target is 9. At line 2, the minimum value is set to 0. And at line 3, the maximum value is set to 3. At line 4, the target and minimum and maximum are obviously the same. And I, the counter variable, is set to the minimum value 0. So at line 5, we would look at the array value 0 to match the counter and take it from there. So see if you can fill that in, and I'll show you the entire trace table in a moment. Stop the lesson while you complete the trace table and then press continue to see my completed trace table. So there it is, eventually returning the value true. Now see if you can do the same thing for the value 99. It will take more rows to do that. So with a fresh trace table, set the target as 99 and follow through the trace table. So if you've done all of the things that I've set in this lesson, you should be able to write linear search as a function. You should be able to recognize it in pseudocode, state the number of operations, which is n, and make a trace table to show how it would find an item in a list or array. So I'm leaving you with a couple of exercises. Complete the trace table exercise for a second time, showing how it would work if the number 99 was the target. And if you're my student, I've also got a worksheet with more trace table examples, and I've got some data structures which you can use, some large data structures to try out your search function. Okay, so next lesson we'll be looking at a new search algorithm called the binary search. So bye for now.